Hello everyone and welcome to the channel. I'm Emmanuel, I'm an Airbus pilot, and in today's video we are going to discuss a very hot topic these days, and those are the Airbus green operating procedures. As the name suggests, these are operating procedures for minimizing the impact your flight has on the environment and likewise obviously minimize fuel consumption. So the procedures in place are basically used by operators to define their own cost reduction policies. Each operator is responsible for the decision of what cost or parameters to reduce, for example maintenance cost, fuel consumption, operating cost and passenger comfort. For example, the purpose of both cost index and flexible takeoff is to reduce general cost, not the fuel consumption. Now, the information in this video is not applicable to all operators to the same extent and depends on their specific operations, such as for example geographical location, airport conditions, local regulations, etc. The flight crew should decide which procedures to apply in accordance with the operator's guideline and the flight conditions of the day, including the aircraft status. So we're going to start with a little bit of general information here, going basically through flight throughout the chronological order. So we're starting in the dispatch, and the first decision there is obviously the decision on the fuel quantity. Now this one might seem like an obvious one, but the flight crew must determine and monitor the necessary fuel quantity at departure from accurate and consistent data such as weather, performance factor, optimum flight level, average wind speeds, etc. Remember, the weight of any extra fuel is going to increase the fuel consumption, and therefore, obviously you do load the amount of fuel required for the flight, but you don't load like too much extra. Now, that might have been rather obvious, but let's now go on with a couple of further items at the dispatch stage. So, fuel reduction is not a factor for the selection of a takeoff configuration. The takeoff performance and best takeoff configuration depend on several operational and environmental factors. The flight crew should select the takeoff configuration that optimizes takeoff performance, such as the takeoff weight, if possible increases flex temperature, and reduces the takeoff speeds, so for example a higher configuration for a dedicated flexible temperature. A higher slat and flap configuration, i.e. slats and flaps more extended, slightly increases fuel consumption, but with a higher flex temperature, such a higher configuration results in a cost reduction. Now, this leads us right to the next point, which is takeoff thrust. When performance permits, use the highest flex temperature for takeoff. Takeoff with a flexible thrust increases fuel consumption compared with the takeoff with toga thrust due to the longer takeoff phase, but the use of flexible thrust reduces engine wear and therefore reduces general cost. Now, going on to the preliminary cockpit preparation, the flight crew may delay for as long as possible the APU start and use the ground electrical unit and ground pneumatic unit when available. Now, in terms of air conditioning, if one pack is sufficient to supply air when on the ground, the flight crew can select one pack to off. In such a case, the flight crew should switch between the packs on each flight in order to prevent excessive wear of one pack. Going on then to the cockpit preparation. On the init page, the flight crew should respectively check that the cost index is consistent with a computerized flight plan, as the CI is the ratio of time cost versus fuel cost. The purpose of the CI is not to reduce fuel consumption, but to reduce overall operating cost. Also make sure that the tropopause value is correct in order to ensure the accuracy of FMS prediction. On the takeoff performance page, if conditions and regulations permit, the flight crew should reduce the altitude for both the thrust reduction altitude and the acceleration altitude as much as is possible. Depending on regulations, the lowest authorized altitude may be 400 feet above the ground. So this is down here on the takeoff page, and on here, rather important, remember the standard noise abatement procedures. You've got noise abatement procedure 1 and noise abatement procedure 2. Procedure number 1 includes the acceleration only at 3,000 feet above the ground. Obviously this means flying at slow speeds with the flaps extended for a longer time, and that is obviously going to increase the operating cost of your flight by increasing fuel consumption quite a bit. Now, likewise, noise abatement procedure 2 therefore is the favorite noise abatement procedure in order to save money in terms of saving fuel, because you can accelerate at a lower altitude. NADP 1 and 2 are the most used ones, and NADP 2 is the default procedure that you will normally use, so acceleration and thrust reduction at 1,000 feet above the airport. Now, the next point then is takeoff runway optimization. The takeoff performance is the first factor to consider in the selection of the takeoff runway. When possible, however, the flight crew should request takeoff on the runway that minimizes taxi time and optimizes the departure trajectory in order to minimize the flight time. So then going on to the next point here, which is before pushback or start. When conditions and air traffic control permit, the flight crew should delay the engine start for as long as possible. This is to reduce time spent with the engines running before takeoff. And before takeoff, the flight crew must ensure engine warm-up in order to prevent engine wear and to maintain engine performance. Single engine taxi obviously is something that can be taken into account and that we will talk about in a few moments. Now, for the engine start itself, it is a very good idea to delay the engine start for as long as possible in order to minimize the time spent with both engines running, where the ground crew is still going to prepare your airplane for taxi. So just try to reduce the time that the engines are running, first by timing your engine start appropriately, and secondly by going to do single engine taxi as applicable. Now going on to the next point then, we've got the after start procedure, and here we can consider something on the APU. So if the APU is not necessary during or after taxi, the flight crew should set the APU bleed to off and shut down the APU. Fuel consumption is reduced when the APU is not running, even if the bleed air is supplied by the engines. If the APU is necessary during or after taxi, for example because takeoff performance requires APU bleed, the flight crew may set the APU bleed to on in order to reduce fuel consumption. This opens the cross bleed valve and automatically closes the engine bleed. As the bleed air is not supplied by the engines, the fuel consumption is reduced. However, the use of APU bleed can lead to exhaust gas ingestion into the air conditioning system, and that is really something that you can smell in many situations when the APU bleed is on while the engines are running. Now, just to visualize that again, fuel consumption with bleeds from the engine and APU off is lowest. Fuel consumption with bleed from the APU and APU on is in the middle, and fuel consumption with bleed from the engines but the APU on is highest. So if you need the APU for takeoff, be sure to also use the APU bleed rather than engine bleed. Finally, consider using the low mode on the air conditioning panel up here. So pack flow low can be done when the amount of passengers in the cabin is less than 60% of maximum, but different operators will have different definitions on when pack flow may be set to low, so just refer to the standard operation procedures there. In the A320, as we have it in the Phoenix version, less than 138 passengers and you can use air conditioning in the low mode. Now, when approaching your departure runway, you may go for the packs off for takeoff, as I've discussed in my video discussing pack operation. Now, single engine taxi is generally a topic that is very much recommended when taxi time exceeds 15 minutes. I have that one covered in a separate video in order to really go into details over there. Now, likewise, in terms of taxi, idle thrust is usually sufficient to move a light aircraft during taxi, and with IAE engines fitted, it can even be sufficient to move moderately, or in some cases even heavyweight aircraft. If necessary, the flight crew should apply only small thrust increases. Remember, excessive fuel burn is caused by excessive thrust and also requires more brake application, therefore resulting in increased brake wear as well, and thereby increasing cost. So if taxi takes a little bit longer but you can keep the engines in idle, that is certainly something that you should consider. Now, in terms of your climb, obviously the cost index econ speed is the most economic speed. However, below 10,000 feet, the airplane is going to default to 250 knots. Obviously, this is not the most economic speed, but it is done to ensure safety by looking outside the window and reducing speed so that collisions can be avoided to a greater extent. However, if you're in an airspace where air traffic control can allow you to fly faster than 250 knots below 10,000 feet, that is going to save a little bit of fuel as well. For the cruise, remember the optimum flight level increases as aircraft weight decreases, so the flight crew should monitor their optimum flight level and do step climbs at the most appropriate points. Now, most appropriate points for step climb, if you look into the flight plan page and you go on to the step outs, you can either define a step climb by entering the altitude and the waypoint from the flight plan, but you can also just go for it like this. So if you only enter the altitude like here, it's going to calculate the optimum waypoint. This takes a little bit, and then you are going to get your distance and time to the optimum waypoint, and down here it's going to tell you how much fuel you are going to save. I'm not 100% sure if that is actually simulated in the Phoenix Airbus, but generally this is what we would do in order to calculate our step climbs. Remember, the optimum altitude that you see on the progress page here is directly influenced by the wind entries as well, so make sure that you have your wind uplinked, and if the wind differs by more than 30 knots in direction or 30 knots in speed compared to the wind uplink that you've got in your flight plan page, then you may want to consider updating the wind information. So, just to show you, our next waypoint here is Podem. If we go into the wind data over here for flight level 360, where we are cruising, you're looking at something like 314 at 15 knots. And if you look at that, that's exactly what we have. So our wind information is certainly good the way it is right now. Alright then, going on from there, it is recommended to fly managed speed as much as possible. Only use selected when you really have to for short-term changes by air traffic control. Now, the flight crew should not modify the cost index in flight, so it is recommended just to keep going at the optimum managed speed. Remember, the speed that you get from your cost index is going to be automatically adjusted for the wind conditions by your aircraft. Now, when you're preparing for the descent and deciding on the landing conditions, it is recommended to use the following configuration in order to reduce cost. That is landing config 3, reverse idle and auto brake low. Now, if the flight crew needs to reduce the landing distance, they should consider the use of the deceleration devices in the following order. Flaps full for landing as first priority, reverser max as second priority, and auto brake medium as third priority only. The flight crew should avoid the use of auto brake medium in combination with config 3 and reverse idle. This is because this configuration highly increases brake temperature and as a result brake oxidation, which may be severe. Now, when the flight crew rides the brakes and overrides the auto brakes on landing, brake oxidation may also occur and increase cost even higher. So, recap from that for your landing planning: auto brakes low is the most optimal setting you can use, together with landing configuration 3 and idle reverse thrust when possible. However, always take additional factors into consideration, as I have explained in my video on how to choose your landing flap setting. So going ahead then, in the actual descent, it is recommended to fly managed speed and fly at the econ speed, which optimizes speed in accordance with the cost index and flight condition of the day. When you have to conduct a holding on the approach, clean configuration is recommended. However, config 1 may be used if you've got holding pattern or speed limitations. Optimum speed in clean configuration is green dot speed in order to optimize the lift to drag ratio. On the approach then, when conditions and air traffic control permit, a decelerated approach should be flown as it reduces fuel consumption. And decelerated approach basically means maintaining config 1 until about 2,000 feet above ground, then go config 2, gear down, config 3 in order to stabilize the airplane. When the approach type does not enable to fly a decelerated approach, the flight crew should fly an early stabilized approach, which means being in landing configuration by the time you pass the final approach phase. When landing performance permits, the selection of config 3 reduces both approach time and fuel consumption. After landing then, the flight crew should delay for as long as possible the start of the APU, and if only the ground pneumatic unit is available at the gate, the flight crew may keep the APU bleed off during transit. One engine taxi again is recommended, and I do refer to my separate video on single engine taxi for that. Now, if one pack is sufficient to supply air when on the ground, the flight crew can select one pack to off. In such a case, the flight crew should switch between the packs on each flight in order to prevent excessive wear of one pack. And there you have it, guys. That's the basic green operating procedures for your Airbus A320 aircraft. I do hope you found this one interesting. If you did, be sure to let me know in the comments below. Leave a like to the video, and if you're up for more, don't forget to subscribe. With that, I would like to say thank you very much for watching. Hope you enjoyed it, and I see you all again on the next one.